everyone. Thank you for coming. So firstly, I'd like to acknowledge the traditional owners of country, the Gadigal people of the Eora Nation, upon whose land the University of Sydney now stands. We would also like to pay respect to elders both past and present, acknowledging them as the traditional custodians of knowledge for this land. And thank you everyone for joining us for National Science Week for our lunchtime talks. And I'm really excited to introduce Arzak Mohamed. She'll be giving a talk about the non-invasive analysis of ancient papyri. So Arzak holds a bachelor in archaeology from the Department of Restoration in Rome, Egypt, and a master's degree in conservation of archaeological materials from Cairo. She's currently undertaking a PhD in the School of Natural Sciences from Macquarie University in the analysis of archaeological materials using X-ray fluorescence spectrometry, X-ray diffractometry, Raman spectroscopy, FTIR spectroscopy, and Scanning Electron Microscopy. And she was also a conservator here at the Chau Museum in 2022, and she'll be speaking a bit about that today as well as her PhD project. And thank you so much.
Thank you, Loreen. Thank you everyone for coming. Happy to see these lovely faces, and I hope you enjoy my talk today. My talk about non-invasive analysis of ancient papyrus. But before talking, I introduce myself. As Loreen mentioned, I have my bachelor degree in archaeology from Fayoum University, Egypt, and I appointed like assistant lecturer in the Fayoum University. I also have my master degree in conservation science, and I was a student researcher at Greenwood Center for Conservation for 1 year, and another 1 year in RMIT University as research fellow. I having a Macquarie scholarship to complete my PhD, and I am working in analysis of ancient papyrus. Before starting my talk, I wanted to hear your thought about what do you know about papyrus? Someone tell me quickly. Yes. Bravo. Well done. Huh? What else? Yes, well done. Tell me, what do you know about papyrus?
Degradation?
Yeah, because it's organic material. Well done, everyone. So today, I am going to talk about technology of making papyrus, past and present. Also, I am going to talk about dating papyrus using the elemental composition. And also, how can science help in conservation science? Conservation and saving this papyrus for the next generation. So we can start quickly. This is the plant, papyrus plant. Papyrus plant can be up to 4 meters. And we can see it consists from 4 parts: roots, rhizome, stem, and the flowers. And there is some example. I took the photo from the Egyptian Museum in Cairo, because ancient Egyptian used the papyrus plant to make papyrus sheets. But do you know other uses of papyrus? Not only making papyrus. We can see it's used in making boot, sandals, ropes, and basket. But regarding making the papyrus sheet, ancient Egyptian make papyrus sheet since 3000 BC, and they used the papyrus plant. But really, they didn't record the technique of making papyrus. Ancient Egyptian hid the secret of making a papyrus. We can't find text describe the technique of making a papyrus, and also no evidence if the technique has changed over time. What we have from information now, from 3 sources. What is the source? First one, description of Bellini in his book, Natural History. Second one, analysis of some scientists these days, they try to identify the material involved in making a papyrus. Last one, some attempts from people to make papyrus, and they try to see how ancient Egyptians try. Maybe use this technique, maybe they use the other, so they try. So this is the source of our information. I spent around 1 year writing a review paper about the technology of making a papyrus, past and present. And I try to put my information in this figure. I designed this figure. It talks about the papyrus plant. So this is the papyrus plant. The only part we use in making a papyrus is the stem. We remove the roots, we remove the flower, we use the stem. After we use the stem, 2 ways we can use the stem. We can peel the stem until we arrive to the core to have 1 sheet from the plant. So 1 plant can make 1 sheet. Another thing, we can slice and have strips. For example, this one, when we peel the plant, we have the vertical and horizontal one. But when we use the strips, we have 6 strips, vertical and horizontal. And we should take care not leaving any space between the strips. The last thing is the pressing. We press the papyrus, the 2 layers together to have a cohesive 1 sheet. So now we learn about making a papyrus. 2 techniques we used, peeling or strips. But what about the material used to prepare the surface for writing? Just put the plant, I have the 2 layers and 1 cohesive preparing. How they prepare? Did the ancient Egyptian prepare the writing to receive the ink? Yes. They used some materials like clay and starch, natron, milk, cedar oil, and big glue. But what is the reason? I have 2 reasons. 1 reason, some of this material antibacterial and anti-fungi. So he can control the biodegradation of the papyrus. Another thing, make the surface ready for writing, absorb onto the ink, and they make it more denser, and cover the holes, if there are any holes, when we put the strips together. So this layer will make the papyrus ready for reading. For writing, sorry. So now, modern times. I searched about making a papyrus these days. I visited Karamos. Karamos, it's a village famous for making a papyrus in Egypt. And they are preparing the papyrus for sale and for gift and export outside Egypt. And I tried to see how did they make papyrus? From where they get this information? So when I went there, I find different technique. They are using chemicals for different purposes. For example, when I told you about antibacterial, and so in the ancient Egypt, they was using natron, cedar oil. But now the situation is different. Prepare the surface for writing, different. What they are doing these days, we can see here. This is the plant, the photo of the plant in Karamos. After that, cultivated the plant and use electric cutter to cut the stem to manageable size. Use nylon thread to have a slice. So now in modern time, they only use strips technique. After that, they used sodium hydroxide, soften the fiber. And also they are using chlorine to lighten the color. But the same technique in strips, if we can see here, yeah, here. In strips, we can see vertical and horizontal. So I have two layers, and they use the carton or cardboard with clothes, linen, and put under press. So this was the technique of making a papyrus, past and present. But from my talk in the beginning, I told non-invasive analysis of papyrus. Why? Why we need to analyze papyrus? Huh? Why? Does anyone can tell me? Why we need to analyze papyrus? Which information we seek to know about papyrus? The date of papyrus? This is something, but if you already have the date in museum catalog, why you need? Suggestion, we need anything, see anything. Authenticate, wow, I like it. Yes, yes. What else? What else? Really? We can use analysis for dating papyrus. We can compare undating sample with one we already know the date and see the similarity in the chemical composition. Authentication, yes. When we compare between fake papyrus and authentic one, we can see the difference. I remember something regarding this point was in the British Museum. Some papyrus came to the museum, and yet it's original because it came from auction. But when the curators and analysts work in this, they find different material, modern material, only used in 19th century, and wasn't during the time of ancient Egyptian. So authentication. So authentication, dating, something important, conservation. Conservation, as I told you before, we need to conserve papyrus. When the papyrus exposure to deterioration from the age, from environmental, pollution, or something else, it can deteriorate and transfer to fragile material. So we need to conserve this object, but how analysis can help us? Analysis can help us by identifying the materials. For example, when we make analysis for the ink, we can decide which kind of ink we are working for. And when we know the ink, we will choose the best or the appropriate suitable technique for treatment. Because, for example, in carbon ink, very sensitive to water. So during my conservation stop, I will not use water. I try to make tests for every material before starting the conservation. So conservation, dating, authentication, more and more and more. And now, so we finished now the first part of my presentation about making papyrus. Do you like it? Really? The second one, it's about my project at Macquarie University It's a part from my PhD. It's about the papyrus from cartonnage. Papyrus from cartonnage. What is the cartonnage? And what is the relation between papyrus and the cartonnage? Cartonnage, it's a protective casing used during Ptolemaic period to cover the deceased body or mummified body to protect from human, from animals, and there is magic spell also in cartonnage that can help the deceased in his journey in after. I can show some example. This is the cartonnage. I have the mummy. This is the mummy. And ancient Egyptian make this cartonnage. Can we see this cartonnage? And the cartonnage developed over the time. First, it was like mask for head and chest. After that, become one piece, cover all the body. Later, it was about 6 pieces, one for foot, stomach, cage, rib cage, and the forehead. But my talking now about papyrus. Where I can see papyrus here? This cartonnage. I'm talking about papyrus from cartonnage. Who can guess? Where is the papyrus here? Where is the papyrus in cartonnage? Melanie. Where? Inside. Bravo, Melanie. Inside. Cartonnage usually consists of several layers. Base layer, preparation layer, and the above one is the painting. So if we can see this one, 3 here. This one is the last one, the outdoor one. So the first one is papyrus. After that, they used gypsum or calcite to prepare the surface for writing, and at the end, drawing and writing. And this is some samples. I analyzed 20 papyri from the Macquarie University History Museum. I tried to identify the elemental and the composition, the elemental and the mineralogical composition of papyrus from cartonnage, and to see if there is any difference between papyrus from cartonnage and the one not from cartonnage. So in this case, I can differentiate between both of them. I tried also to see the difference between papyrus in different age group, because I classified my samples to 3 age group, 299 to 200 BC, another age group, 199 to 100, last one 244 and 245. And this is the instrument I used in my study in Macquarie University. I used X-ray fluorescence and I used X-ray diffraction. X-ray fluorescence, there is different type from X-ray fluorescence. I prefer this one because it can make mapping to the papyrus surface. And also, as we can see, it's safer. There is closed chamber, and I can put my sample inside the instrument. X-ray diffraction, I use this instrument because, as I told you in the beginning, I am focused in non-destructive techniques. Most of the samples which we use XRD, we need to grind the sample, transfer the sample to powder. But because of the valuable and the value of the papyrus and the text, the writing on papyrus, we can't touch this document. So I try in all my research to search for non-destructive techniques or non-invasive. And how I measured the sample. As I told you, I have 20 papyrus sample. Regarding X-ray fluorescence, I measured around 40 points, 40 measurement on each one, 15 in inked area, which I have the ink, and another 15 on non-inked area. So the circles, and some of the papyrus has white material. I also tried to see, what is this white material? So I measured these spots. And what I found, most of the sample I tested, there were high concentration of calcium. High concentration of calcium. So I realized this information can help us to understand the technology, because I told you before that papyrus is the base layer, and after that preparation layer, and then the drawing or writing. So now when I have calcium, okay, so I have calcium, what I should do? It's the material used in preparation layer has calcium in their composition. It could be calcite, CaCO3, or it could be gypsum, Ca2SO4 to H2O. So I searched what I should do. I need to understand the mineralogy. I am not able to. Okay, X-ray diffraction can help us. I took the sample and I make analysis using X-ray diffraction. And what I found, this is the X-ray diffraction. X-ray diffraction gives us the mineralogical. For example, like salt, food salt, sodium chloride. If I used X-ray fluorescence, it will give us me sodium. But when I used X-ray diffraction, it will give me sodium chloride. So that is why I searched it. And I found that this white material is calcite. So and now I can understand the technology. Calcite was above the papyrus. Another thing, this one is very important. When I collected my data for all the analysis, I used statistical analysis to help me to understand this data. And I read about cluster analysis and using a cluster analysis to classify the objects. I think how I can use cluster analysis in dating. I have two unknown samples, which we have circle, and I used the analysis of them, and they have this figure. This figure contains the 20 papyrus, the 20 papyrus samples I have. And when I make the classification put my samples, please unknown samples with this. So I think, why? And when I checked, I found that depending on the clues or the similarity in the elemental composition. For example, I found that papyrus 449 is close to 389. Okay, so I already know one of them. I can assign the other one to the same age group and similar. So now I am able to date papyrus using the elemental composition and also understand the technology. And my paper for this research under review now. I hope they accepted. So first, again, we understand the technology in making a papyrus, past and the present. We moved to papyrus from cartonnage, and we understand the technology, and can we have dating on papyrus? New thing, read it with conservation. This one. I got the chance last year to work here in the Chau Chak Museum as a papyrus conservator. And thank you, Melanie. And thank you also for Veronica and Mary, because they introduced me to Melanie, and really I am happy and appreciate this opportunity. And when I came here, I have some papyrus, and we need to make conservation for this papyrus. And as I present only one of them today, this is papyrus. It's from the 3rd century BC, and it was in Saqqara. We found in Saqqara. So I tried to see what is the deterioration in this papyrus, what we can see. For example, I can see dust accumulation. The papyrus fiber need to be cleaned, missed parts, and misplaced fiber. It means the fiber is not the correct position. Another thing about twisted fiber, I need to return to the correct position. And this is, for example, what was interesting for me, I can see gold. I feel it's a gold in the decoration. And also there is some writing, red writing. What is this? I tried to search. So I told them, okay, we can make project about analysis and conservation at the same time. And we started our project. Before touching or starting conservation, we identify most of the material exists to choose the best technique for treatment. So this is the instrument we used. We used Raman spectroscopy. We used Arzak spectroscopy, this kind of XRF, and we used FTIR spectroscopy. But why I choose this instrument? Because every instrument has a specific task. So I can obtain the information I need. For example, when I used Raman, I wanted to identify the kind of black ink I have. It's carbon ink, Rungal ink. It's a mixture between them to decide which treatment I should use. When I decide to use Arzak, I want to identify elemental composition of ink and also for red writing, and if there is material involved in the surface of papyrus. I used FTIR spectroscopy to identify the organic material. So we can see now, this is the X-ray fluorescence for red ink. As we can see here, this is the red ink we found in the papyrus, because it was using the red ink to write the important information, name of persons, date. And I found that ferrous is the main compound. So hematite is the main compound of preparing the red ink. Another one, gold. And this one, I was gold. But unfortunately, when I make the analysis, I didn't find gold. I found arsenic. And when I searched it, I found it is orpiment. And Melanie was excited. Lorraine also. Wow, it looked like gold. But really, orpiment give us the opportunity to know orpiment also used instead of gold in making the papyrus. And this one, the black ink. But really, X-ray fluorescence didn't help us a lot in identifying the ink, because X-ray fluorescence can't identify the carbon. And this one, for non-inked area. And as I told you, when I make the analysis and I am not able to identify the kind, what is the kind of carbon ink or the black ink, we conducted analysis using Raman. Different spots on the papyrus sheet was analyzed, and as we can see, this is spectrum, which show us the D band and the G band of carbon ink exists. So now this is the carbon ink. we come to the step of conservation. I start the conservation. The first thing of conservation, I need to make tests for the ink. We have to see the sensitivity of the ink for water and also for the cleaning solution. I prepare different solution, 50% water, 50% ethanol, 25, 75, many things. And I try to check which one can give cleaning and also doesn't cause any issue for the ink. I was test using blotting paper, and I damped in the solution. I covered for around 5 minutes, and I check if there is any effect on the paper from the ink. This one, I try to test the acidity of the papyrus. If this papyrus suffer from the acidity, because really acidity is very harmful phenomena in papyrus, and it can come from the ink itself. If the ink is iron gal ink, it can cause acidic deterioration, or from the support, if we has carbon or cardboard as the secondary support, and also from the light, degradation from the light. I test using these strips. This strips has number from usually from 0 to 14. And when I put the slide, the strips, and put little bit drops of water, and this is the effect, and compare the one I have like this, the strips color with the one in the container, I can see. And when I checked, it's around 5. So I don't need to make any intervention because already the papyrus is not acidic and not suffering from acidity. Cleaning. I started cleaning. I used a different technique in cleaning. I used brush. And when I used the brush in cleaning, I was careful. I tried to take care, make the direction of the brush in the direction of the fiber. Another thing, I used wet cotton swab. And after that, I used dry one quickly to avoid any effect from the cotton swab. And sometimes I used spray the cleaning solution in blotting paper, and I cover the place which I need to clean and will the swab after that. This one, joint tears. Papyrus in this object has some tears and divided to separate places. I need to collect all together. And that is why I use the strips. This is Japanese paper strips. I try to have small strips to connect this papyrus together. And when I use these strips, I try to use the strips in non-inked area. So I will not able to cover the ink. Last thing, we come to mounting. I tried my best to find the best suitable technique for mounting. I used 2 pieces of glasses, 3 millimeter, and I cleaned this surface to avoid any dust. And I used the film blast to seal the collection. But because the size of this papyrus is very big, I used in the back blotting paper, free acid, that will not cause in the problem any issue. And also I take care of something, film blast. The film blast or the seal I used to cover the collection, acid-free and easy to remove in the future. If we decide we want to open and have the papyrus from inside, easy, just wetting with some water, and we are ready to make any treatment for papyrus. And this is some of my publication. I'm making a review. I already have a review about making a papyrus. Another thing about treatment of papyrus in Egyptian Museum in Cairo. And also I have some testing. I try to test a consultant to see which technique is good for papyrus technique. Yeah, thank you so much. Still have time, or it's okay? I have lots, but it's okay. If you need more. Do you have any question? If you ask a question, one chocolate. No, and sometimes we found in British Museum 3 layers. Yes, but it's like not always can exist. Few bases. Yeah. Yeah, natron. Natron, it is a salt. It is the kind of salt from sodium salt, sodium chloride, sodium hydroxide, sodium carbonate. And this kind of salt exists in Wadi Natron in Egypt, and they used the water during the preparation of papyrus. So when they wanted to make papyrus, okay, we will have some and we'll prepare. And sometimes they prepare the papyrus near Wadi Natron, so they can easily have access to this kind of salt in preparation of the surface. Yes, similar. Yeah, yes. So we can now understand why these days they try to use different. And also sodium hydroxide is cheap, available, and they can produce a huge amount of papyrus. Yes, preparation the surface. Prepares the surface, makes us cover any holes in the surface, makes the surface straight and smoother. And also, it can make the surface less absorbent for the ink. When I write, not all the ink can penetrate inside. I can have some in the surface. And as I told you, anti-biodegradation. I will avoid any fungi, bacteria, any insect to attack this papyrus. I already have a treatment for the papyrus. Yes. Yes. No, I will tell you. Non-destructively, because every company has development in making the instrument. The first stage of XRD, I need to grind the samples to put inside the instrument. But if we come back, it would take long. Just a moment, wait. Yes, this one. If you can see the glass and you can see the papyrus above the glass, this is the analysis. This is the stage of putting the sample. So I bring the papyrus, I put above the stage, I close the instrument without doing any destructive thing, without any preparation. I can have my result. Just. And there is another technique, modern. You can choose which spot you need to make analysis for. Yeah, micro XRD. Yes. Big glue. Yeah. Yes. And the antibacterial and yes, propolis, yeah. for writing. The ancient Egyptian old used a black one and the red one. But for other decoration, they used a different color with different material. So in drawing, yeah, different. But in writing, the ancient Egyptian stuck with using carbon ink for writing, or the black ink for writing most of the text, the body text, and red ink for writing the date, the name, some important information on papyrus, like the owner of this papyrus. Thank you so much. Yeah. Vertical. The horizontal one will be in the back, and the vertical to write in the direction of the strips. So just a moment. In the back, this is the side, horizontal one, and vertical one on the other side, and you write in this, in the direction of the fiber. Yeah, so I can decide which is the back and which is the front. Yeah. I hope you enjoyed, really. Did you enjoy? Thank you everyone. Thank you so much. And this is my email if you want to contact, you need any information about papyrus, anything.